Okay, today we're going to start 2.4, and we're going to start with polynomial long division, then we'll do synthetic division. The ones I ask you to do by long division, please do by long division. I don't want you to only do the hard ones by long division. I want you to practice with some of the easy ones so that the hard ones aren't so bad. Generally, you only need to do long division on the harder ones, but again, it'll be easier if you practice with some of the easy ones. So we're going to start by dividing some polynomials. In fact, we're just going to do this one. This is a piece of example 4, or example 2. I'm starting with this because example 1 is a hard one, so we're going to start with an easy one. So when I set it up, the second part, known as the divisor, goes in front of the division sign. This is not a square root. Don't make it look like a square root. Okay, I'm going to check how many times this first thing, whatever the first thing is, goes into this first thing. That's 3x squared over x. I can think of 3x, what times x is 3x squared, or I can think of it like this, 3x squared divided by x. That cancels an x, and I get 3x. I now multiply these by this x plus 4. 3x times x plus 4 is 3x squared plus 12x. Oops, I shouldn't write the plus. I usually don't write the plus. Was not supposed to erase all of that. Okay. In general, you subtract. I like to add negatives, which means I change the signs and add. I say I change the signs and add. Notice I also lined up the x squared with the x squared and the 12x with the 7x. 3x squared minus 3x squared cancels out, and I get negative 5x for 7x minus 12x, and I bring it down. I look then at the front thing. X goes into negative 5x, negative 5 times. My x's functionally cancel out here. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20. Change the signs. They both become pluses. I get a remainder of 0. Okay, remainder of 0 means, well, 3x squared plus 7x minus 20 means it is a factor. It means x plus 4 is a factor and 3x minus 5 is the other factor. Okay? So if I tried to factor this, I would get 3x minus 5 times x plus 4. If the remainder is not 0, it is not a factor. Okay? I'm going to do one here in a second where the remainder is not 0. Okay? And I'm going to divide this 2x squared plus x plus 1 divided by 2x to the 4th minus x cubed minus 2. Well, I'm going to leave a space or put in some zeros for the x squared and the x term so that I've got space when I'm multiplying to put them in. I start with my firsts, 2x to the 4th, and I divide that by 2x squared, which equals x squared. The book lines it up over the x squared term. It doesn't really matter. X squared times 2x squared is 2x to the 4th. X squared times x is x to the 3rd. X squared times 1 is x squared. I change all my signs, giving me negative 2x cubed minus x squared minus 2. I guess I'll bring down my plus 0x as well. Negative 2x cubed divided by 2x squared gives me negative x. Negative x times 2x squared is negative 2x cubed. Negative x times negative x is negative x squared. And negative x. I'm going to change all my signs. All these negatives become pluses. I usually only write signs in if they're negative so that I can cross them to make them a plus. If there's nothing else, I'll then insert the negative when I switch signs. Both of my first two terms cancel out, and I get x minus 2. Now I see, does 2x squared go into x? The answer is no. My remainder is x minus 2. So I can say my answer is x squared minus x, either r x minus 2, or the pre-calc way of really saying this is x squared minus x plus, I take my x minus 2 and I write it over the thing I'm dividing by. 2x squared plus x plus 1. And this is really the best form of the answer. This is what you should give as a pre-calc student. That is polynomial long division. We're going to talk about synthetic division. Here I've got 2x cubed minus 3x squared minus 5x minus 12. You put it in parentheses and divide that by x minus 3. This works when it is a first degree, an x minus or an x plus. When there is no coefficient in front of the x, it's just x minus 3, x plus 7, x minus 2. And you probably want these to be whole numbers for the threes. In my little box over here goes, what is the solution to x minus 3 equals 0? That's x equals 3, so I put positive 3 in the box. I then take my coefficients. Now the last one, remember, I put in 0x squared and 0x. If you miss that in long division, it won't line up with anything and you'll probably catch it. You cannot miss things like, if there's a missing power as I go down, say an x to the, if this was an x to the 4th, I would have to do a 0 where the x cubed would be. If this 5x weren't here, I'd do a 0. But otherwise, I just take the coefficients with the signs and put them down. I start by just bringing this first number down. Then I take 2 and I multiply it by 3 and I get 6. Negative, now I add. Negative 3 plus 6 is 3. 3 times 3 is 9. Negative 5 plus 9 is 4. 3 times 4 is 12. This box here at the end is the remainder. This is 4, this is 3x and 2x squared. There are two ways to do this. You can realize that I started with an x cubed, I divided by x, so the first thing has to be an x squared. Or you can realize 4 is a constant, and I count up 4, 3x, 2x squared. Yes, x minus 3 is a factor. Let's do something that I'm going to make up and probably won't be a factor. So in my box up here, the solution to x plus 5 equals 0. Well, what x value makes x plus 5 0? That is negative 5. 4, I don't have an x to the 4th, so I need a 0. I don't have an x, so I need a 0. Bring my 4 down. 4 times negative 5 is negative 20. 0 plus negative 20 is negative 20. Negative 20 times negative 5 is positive 100. 97. Negative 5 times 97. This is 485. That's negative. Minus 7 plus negative 485 is negative 478. Now I need a calculator. These, if they're not careful, get real big real fast. Negative 478 times negative 5 is 2,390. That times negative 5 is negative 11,950. Negative 11,952. So what is the quotient? 4x to the fourth minus 20x cubed plus 97x minus x squared minus 478x plus 2390 minus 11952 over x plus 5. So again, starting with what I divided by. An interesting property of synthetic division. If I say p of x equals 4x to the fifth minus 3x cubed plus 7x squared minus 2, p of negative 5 will equal my remainder. Unless I made a mistake, which I don't think I did. That means if I plug in negative 5 for all the x's, I messed up here when I wrote this out. Negative 5 is to the fifth. I don't know why it's erasing more than I want it to. There. And then minus 2. I'm going to check that on the calculator. And voila, I get negative 1,952. With the calculator, it's not really a whole lot different. But if I had to do that by hand, it was actually quite a bit easier to do that with synthetic division. Okay. That is your lesson for today, I believe. Let me double check that I covered everything. And I think that's the first part of what you need for long in synthetic division for 2.4.